the problem is about throwing this ball up. Okay, and the ball goes up, and the ball comes back down. Now, in this problem, we want to find how long it takes for the ball to go to the top, for the ball to come back down, and what is the distance that the ball goes up. And we also want to find what its velocity is when it comes back down to the same height. Now, in order to do this, to find all this, we need to know the acceleration. Now, we'll learn later on, when we learn about Newton's law and about forces and weights, that if you throw something, the acceleration of the thing, if we ignore the air resistance, the acceleration is always downwards because of gravity. And the value is, to be precise, it's always 9.81 meters per second squared. Okay, 9.81. But for this example, just to make it easier to calculate, I'm going to approximately to say that this is approximately 10 meters per second squared. So just so that I have a simpler number to calculate with. Now, there are one or two things we need to clarify about what it means by saying that this acceleration of a falling object is 10 meters per second squared. The meaning is clear enough if say we think of a ball that just keeps that we drop and that keeps falling and falling. It means that every second the speed increases by 10 meters per second. Okay. What is more tricky to understand is what happens when we throw the ball upwards. Let's say if we throw the ball upwards, obviously, all right, we know that if you throw something up, it slows down, and then at some point it stops and it has to come back down. So what do we mean by saying that the acceleration is 10 meters per second squared and downwards? Right. What this means is that if we have an acceleration of 10 meters per second squared downwards, what it means is that the velocity, okay, the velocity, that means this velocity here, it decreases by 10 meters per second, right, as the ball goes up. So whereas on its way down, the velocity increases by 10 meters per second every second. On its way up, the velocity decreases by 10 meters per second every second. That's why eventually the velocity decreases to 0, somewhere there, and that's when it starts pulling back down again. So that's how we understand this this statement, that the acceleration of, we call it acceleration of free fall, is always 10 meters per second squared, or to be precise, 9.81 meters per second squared, and that it is always downwards. So having clarified what this means, let's start with the first example. Okay, now I'm going to let me just clear this out. I'm going to think about just the upward motion for now. I'm just going to think about the upward motion. So the ball, okay, this ball, I'm going to throw this ball upwards. Let's say I'll throw it up with with a speed of maybe let's say 5 meters per second. Alright, I'll throw it 5 meters per second. Maybe that's quite hard. Okay, so this ball flies up. This ball flies up, but as it flies up, it slows down. Okay, it slows down until at some point it slows down to a stop. Okay, that's when it starts to fall back down again. So when it slows down to a stop, that's when it just stops instantaneously. Okay, it stops instantaneously before it comes back down. Now I want to find two things. I want to find the time. I want to find the time it takes to go to the top. I also want to find how high it goes. All right, I want to find the distance that it goes up in. So that will be my displacement. I'll call that S. Okay, so S is the displacement upwards. Okay, and the information that I have, okay, as I have described just now, I have this information that that the acceleration is always downwards, and that the acceleration, I'm going to take the approximate value of 10 meters per second squared. Okay, so let's look at this and see how we can solve the problem. Now, the values that we are given, let's have a look at the values that we're given. We are given the initial velocity. Okay. That's my initial velocity, which I call U, symbol U. That's 5 meters per second. My final velocity is V. Alright, I take as final velocity the point where it reached top. That's where it stops, right? So V is actually 0. V is 0 meters per second because it stopped. Okay, and let's see. Right, and we have the acceleration. This is A. That's A. So I know V, U, and A. And we want to find T and S. So these are the question marks. I want to find T and S. I have to decide on finding one first, either T or S. So let me pick T. Okay, I'm going to try to find T first. So the information the variables that are involved, the quantities that are involved right now are U, V, T, and A. Okay, U, V, T, and A. So let me remember that U, V, T, and A. I'll go back up there. I'm just going to write this down. U, V, T, and A. Alright. So what I need to do is I need to look through these 4 equations and see which of these contains U, V, T, and A. And it's just the first one. It's just the first one. Contains U, V, and T, and A. And I want to find T. Alright, I've decided that I want to try and find T first. So from this equation, I want to find T. So the way I would do it is I would rearrange this equation to make T the subject. Okay, T on one side so that I can calculate it as a formula. Okay. Now I have already done this in the previous video, so I'm just going to write down. This time I'm just going to write down the formula that I have. So if I rearrange the formula, okay, I'll just quickly write it down. The formula was v is equal to u plus at. If I rearrange it, this is what I get. T is equal to v minus u over a. Okay, and I can now substitute the values that I know. Now let's go back to the velocity that I need. The velocity has direction, right? The velocity has direction, and since this is an up and down motion, is a motion along a straight line, I can decide to choose whether I want to choose the up or the down as positive. Now usually it's natural to think of up as positive, or if you have left and right motion, you think of the right as positive. But I'm just going to show that it works whether or not I choose up or down to be positive, as long as I follow it through, I stick to this in the problem. So I am going to choose right, down to be positive. Okay, just to be different, just to be special, I'm going to choose down to be positive. I'm going to show that it's fine, right? It really doesn't matter whether I choose up or down. But since I choose down to be positive, I can now start giving signs to the velocities and acceleration. The velocity, the upward velocity is the starting velocity u is upwards, so therefore it is in the negative direction. So that should have a minus sign. Final velocity is 0, so that don't need a sign. Acceleration is downwards. Okay, so it's positive. So that's a plus. So there we are. So we have now all the numbers that we need. I'm now going to substitute it into this equation, starting from v. V is where it stops. So v is actually 0. 0 minus u, right? U is minus 5. So minus of, okay, I'm going to put a bracket here. I'll call this minus 5. Okay, so that I don't confuse the two minus sign side by side. Okay. The next number I need to put in is for the acceleration, which is 10. And the sign of that, let's see, so it's 10 and going downwards, so the sign is plus, it's plus 10. So we have our answer actually. On the top we have minus of minus 5, so that's plus 5. Plus 5 over 10. 5 over 10, and 5 over 10 is equal to 0.5, and it's time, so that's in seconds. So that's our answer. It takes 0.5 seconds for the ball to reach the top. So that is fine. We have the answer now. Okay, let's go on now to find the upward displacement. That means the height of the ball when it reaches the top. So to find this, let's look at what numbers we have. The starting numbers would be, let's see, u, we have u, v, a, and we want to find s. Actually, we now have t also, but just for this example, I'm going to ignore t, and I'm going to see how I can actually find the answer using just v, u, a, and s. v, u, a, and s. So let me go back to my 4 equations. Okay, I'll write down what are the quantities involved here. U, V, A, and S, and it's S that I want to find, right? Let's look through all the four equations and see which of these contains U, V, A, and S. So let's see, U, V, A, and S. That would be this, right? This contains U, V, A, and S. So this is what I need. Brilliant. And since S is the one that I want to solve for, this S, I'll do it by rearranging this equation to make S the subject. Okay, so let's remember this equation. V squared equals to U squared plus 2AS. So go back here. Right, let me clear this. And write down the equation. Here, V squared is equal to U squared plus 2AS. And S is what we want to find. So let me rearrange this to make S the subject. So first of all, S is down here. So I'll get rid of that by subtracting U squared from both sides. 2AS. Next, just to have S on only on one side, I'm going to get rid of the 2A by dividing both sides by 2A. So if I divide both sides by 2A on the right hand side, it's just S now, and on the left hand side I have V squared minus U squared over 2A. And now I can find the answer because we know V, U, and A. Alright, they are here. They are V, U, and A. We know these numbers, and we have already decided on the signs. So let's put this in. Right. S is equal to, now V squared minus U squared, right? So V squared is 0, 0 squared. U squared is here. U squared is minus, U is minus 5. So 0 squared minus, and let me put a bracket there. It's usually safer when I have a minus sign, so that I don't get mixed up with the sign outside. So U is minus 5 squared. Okay. Divided by A, 2A. Okay, and A we know is plus 10. So here we are. 2 times 10. Okay, so we have all the numbers that we need, really. And on top I have 5 squared, and I just clear out all the signs. Let's see. I have a minus sign, right? The minus sign in the bracket disappears because it is squared, but I still have the minus sign outside it. So there's a minus sign here over 2. Now let's see. Just gonna make things easier by okay, at the bottom I have 2 times 10, right? So how can I make this calculation a little bit easier? I can use the calculator, but what I'm going to do is this. I'm going to say, right, I'll be since I have 5 as a factor both on top and at the bottom, I'm going to divide top and bottom by 5. So if I divide top by 5, 5 squared becomes 5. Bottom by divide by 5, 10 divided by 5 is 2. Right. So therefore I have minus 5 over 2 times 2, which is 4. Minus 5 over 4. And we're talking about displacement here. So units is in meters, minus 5 over 4 meter. So there is a minus sign. What does it mean, a minus sign? Well, it means that from the starting position, I have a displacement in the negative direction. Now remember that I've chosen downward to be positive. Okay, so negative direction means upwards. So I have a displacement upwards. Okay, from there all the way to the top. Okay, and that's the direction of the displacement which we found from the answer because of the minus sign. And the size of this displacement, the magnitude, is 5 over 4. So write this down. So this displacement is 5 over 4 meter. So we have S.